In this video, we're going to answer some questions about data using the empirical rule, also known as the 68, 95, 99.7 rule. This rule is a great shortcut to help us determine the percent of data that is between certain values, as long as those values are on a multiple of the standard deviation. We can see the empirical rule in this figure. In the middle, we have our mean, which is mu. And if I go back one standard deviation and forward one standard deviation in this light area in the middle, that is 68% of our data. Technically, it's a little bit more, but for this rule, we say approximately 68% of the data is between one standard deviation below and one standard deviation above the mean. Another way to say that is that 68% of the data is within one standard deviation of the mean. If we move out two standard deviations, so we go over to here, two standard deviations forward and two standard deviations backwards, you can see you've got the light blue area plus this light purple. All of this area represents 95% of the data. So when we say that normal curves have most of the data near the mean, we can see that illustrated pretty clearly in this rule. Within one standard deviation, we have more than half of the data. And then within two standard deviations, we have almost all of the data. If we go out a little bit farther, 3 standard deviations this way, 3 standard deviations that way, within 3 standard deviations of the mean, we have 99.7% of all data. That means only 0.03% of the data is outside of 3 standard deviations of the mean. The two circled areas combined are the 0.3% of the data that is outside the 3 standard deviations. Because there are 2 of them and they are symmetric, so they're the same size, that means in this circle we have 0.15% of the data, and in this circle we have 0.15% of the data. So our empirical rule tells us that most of the data is within one standard deviation of the mean, that's 68%, 95% within 2 standard deviations of the mean, and 99.7% within 3 standard deviations. It's only a very small portion of the data that is outside of 3 standard deviations of the mean. Now this 68% comprises all the data from 1 standard deviation below to 1 standard deviation above the mean. We can break this down even further into each individual section. So here we can see between the mean and the mean plus 1 standard deviation, we've got 34% of our data. And between the mean and 1 standard deviation below, we've got another 34% of the data. Between 1 standard deviation below and 2 standard deviations below, so in this interval, we have 13.5% of the data. So this part in yellow is 13.5% of the data. And by symmetry, we have that same amount over here. Between 2 standard deviations above and 3 standard deviations above, we have 2.35% of the data. And again, by symmetry, we have that same amount on this side. And then on the very outside, out past 3 standard deviations, this is the 0.15% we talked about earlier, same thing over here. So where did this 13.5% come from? We can see the 13.5% by considering our 68, 95, 99.7 rule. So if this portion in here is 68, and this portion from here to here is 95, 95 minus 68 is going to give us 27% of the data. So that's saying that there's 27% of the data within the 95, but outside the 68. That would be this area and this area as well. And then since there are 2 of them, 27 divided by 2 gives us our 13.5%. That's how we got the 13.5% that is present right here. This figure is very useful in solving the normal distribution problems that ask for percents between values that are on standard deviations. For example, here I've got a test score with a mean of 75 and a standard deviation of 8. This is the same figure we saw before. For the mean, I've got a 75. If I go up one standard deviation, that's at 83. Up another standard deviation, that's at 91. And up 3 standard deviations is 99. So I could read this as 0.15% of the test scores were above a 99. Here, if I go backwards, 75 minus 8, going back one standard deviation, I have a 67. And then I go back again to 59, and I go back a third standard deviation to 51. So all of these values are different values for test scores on this normal curve. If I want to know the percent of test scores between 75 and 91, I'm looking for the percent of test scores in this range. So between 75 and 91, to find that percent, we're just going to add together the values that were shown. So we've got 34% in the first chunk, plus 13.5% in the second chunk. That's going to give us 47.5% of the test scores between 75 and 91. All right, next question. What percent of test scores are below 67%? In this case, we're looking at the test score is 67 and everything that is below that. So all of this. All right, everything in yellow here. Again, we can find those values by adding together what's in those chunks. If I'm at 67, the percent between 67 and 59 is 13.5%. The percent between 59 and 51 is 2.35%. And the percent between 51 and the lowest possible score, which would be 0, is 0.15%. If we add these together, we get 16%. All right, the last question on here says, what percent of test scores are above a 67? There are two ways to do this. The first way is to notice that the percent that are above 67 will be 100% minus the percent that are below. That's because the entire area under the curve represents all of the test grades. So underneath the curve, we have 100% of the data. If we have 100% minus 16%, that gives us 84% of the data above a 67. In other words, 84% of all the test scores are above a 67. The other way to do that is to just add together the percentages we have here. 34 plus 34 plus 13.5 plus 2.35 plus 0.15 also gives us 84%. So this empirical rule, the 68, 95, 99.7 rule, gives us an easy way to answer percent questions as long as the values we're dealing with are on multiples of our standard deviation. It is especially useful if you have this little pictorial with you, so I suggest you keep a copy of that next to you when you're doing your work.